2017 C2 structural forms. Okay, so the image on the right shows a sun canopy, so I'm just reading from the question, of an umpire's chair at a tennis tournament. Okay, it shows the projections of a hyperbolic paraboloid generated by translating the curve ABC in the vertical position along the parabola DBE. B is the vertex of both parabolas. Okay, and you're given the kind of drawing directly underneath. Okay, so this parabola ABC is going along this parabola DBE. What you were asked to do, there are 4 parts. The first thing you have to do is draw the given plan of the canopy showing all points of tangency. They're all points of contact. Then you're going to have to draw the end view, which is just a parabola. The first thing you will need to consider is to scale. It says scale 1:5. That means with every measurement, 700, you're going to divide it by 5, you'll get 140. Divide the 200 by 5, you'll get 40. Divide the 150 by 5, you'll get 30. Divide the 700, you'll get 140 on both sides. And divide the 175 by 5, and you'll get 35. We are starting off with a plan. It is all circles in contact with each other with a few tangents involved, and you're going to have to show the points of contact. So I am starting with a center line measuring 35, 140, 35. In the center of the 140, which is in 70, you're going to do a vertical line. So I have this kind of set up on my page, just very briefly. So on my page, I've done the grid. Okay, I started off with my center line along the middle here. I've measured the 35, 70, 70, 35. And it's the plan I'm starting with, so I'm going to just bring it into focus on my screen. And that's where we're beginning from. So grab your compass. There are 2 circles on the left and right hand side, and the measurement of it is 35. So draw those in lightly first, because we don't know how much of this is going to be heavy. Okay, you don't really need the whole circle, but we might as well draw it. Same on the opposite side. Once you have the circles done, you will see that there's 60 degrees drawn from each center point of the circle. So you're going to come out 60 degrees on 2 surfaces to the left, and then 60 degrees from the 2 circles to the right. Okay, so at this point you have 4 points of contact, because these will be tangential to the other curve. Okay, so they're my 4 points of contact. That's what I was asked for. A point of contact creates a tangent which is going to be perpendicular to those lines. Perpendicular to 60 degrees is 30 degrees. And actually, before I did that, there's meant to be 2 60 degrees going from the very center of this as well. So I'm just going to put them in also. Okay, so I have the 2 60 degrees in through the center. Where the 30 degrees touches that is yet another point of contact on both sides. And same on the bottom. Point of contact. And again, another point of contact. So on this sheet at the minute, you've 1, 2, 3, 4, 5, 6, 7, 8 points of contact. Now, the last thing we need is a curve joining those 2 points. It says the radius is from the center point out to the tangent. So put your compass on the center, stretch it out to the point of contact, and draw your arc in. Same on the underside. Okay, and now you can start putting in the other curves in heavy, because you know where they're going to be heavy. Okay, and you can put in those tangents in heavy also. Okay, so that is the plan complete. And that was part A of the question. So just label it part A. Part B of the question is to draw an end view. And I'm just going to bring my end view into focus now. That's part A. You'll bring the two outside points and the centre point out to the edge of the object. You're going to bring them up at 45 degrees and you're going to get a baseline for your elevation and end elevation. So basically, up here to the right hand side is the positioning of your parabola, and it's going to be 30 millimeters off the ground. So you have your 30 millimeters and 40 millimeters and a bit of a gap. I left about 10, I think. So my parabola needs to go in this rectangle. And as you know from before, you're only actually dividing 1/2 of the parabola. So we can start on that now. It doesn't really matter the divisions on it. It is completely up to you. What I did is I divided it up into 4. Simply because this was 40 tall, so that's an easy one to do. So because it's 4 10s, it's easiest to just use your set square for this. Sorry, my screen just went. Okay, so I have 4 points on the outside here. I need to get 4 points on the base, and this requires line division. So draw a line out at any angle. Measure your 4 points on it. And transfer it back to the opposite side. Nothing tricky so far. This is all junior cert drawing. There's nothing new here. Now, because this is my axis and this is my point B, I need lines parallel to the axis, because you would have learned doing conics that both points go to the 2 vertices in the conic. And in a parabola, the second vertex is at infinity, and that's what we're drawing here now. So these lines are at infinity. The ones on the far side go to the near vertex, which is this one, and that's why you're joining them there. First with the first, second with the second, third with the third. And you're going to transfer these also. So you're going to transfer those points over to the left hand side. Let's bring the first one, second one, and third one, and the fourth one is obviously the last point. Grab your compass in order to transfer them, and that will be the end view done. Now that you have all of your points, you can draw that curve in. A little bit trickier when you're doing it upside down, but just do the best you can. You can turn your board or sheet to make it a little bit more accurate. Okay, so there is the end view done, and that is part B of the question. So again, just label it part B. Part C of the question asks you to get the front elevation of the canopy, but it told you in the question, and I'm just going to bring it back to you there for a second. It told you in this question that DBE is a parabola, so that's this curve here is also a parabola. It's a height of 30, and you know you have your width there, it's the overall width. So you should be able to transfer your points from plan up. So basically take the 2 outside points, bring it up, bring the centre point up, and this rectangle over here to the right hand side, that's what I'm dividing up. To make sure I divide this up correctly, it gives you a little hint in the question. So all of these sections will help you draw this curve up on top. So this parabola ABC is this one in the middle, and it's telling you that there's 1, 2, 3, 4, 5 divisions in each of the surfaces. So that means this space needs to be divided up into 5. So use line division like you've done before. I'm just going to actually do it above here. Measure 5 places on it evenly. I'm just going to go up in units of 2. Bring the last point over to the last point on the line and then slide. Now that you have that done, you'll need to divide the side into 5 as well. Okay, so I'm just going to do that out here. Measure 5 places. Because it's 30 millimeters high, it will be 6 millimeters for each one, and you can't really accurately measure that. So it's best to do line division for it. So measure 5 places and bring it out to the outside edge. Okay, so now that I have both surfaces divided up, this is my axis and B is my vertex. And I'm just going to label my ABC over here actually, just to keep it consistent. I'm going to label D to the left hand side, and I'm going to measure E to the right hand side. So I have my D, B, E. This is my axis, so I need lines parallel to my axis. Again, because the second vertex is at infinity and that's what I'm drawing. Points on the outside go to the near vertex, which is this one, B. First with the first, second with the second, and so on. I'm just going to draw that in just so I'm not getting confused with all of the construction points that I've drawn in. Okay. Transfer these to the other side. Okay, again, grab your compass in order to do that. Okay, now that you have all of the points, you can draw that full curve in. Okay, you'll need to start getting your tracing paper ready now. Okay, I have mine already ready, but I'll go through how to get it again. So, I have mine drawn on, but I'll explain how you get it. In order to get this top curve, this parabola is moving along all of these points. And I'm actually going to put them in plan so you can see them a little bit clearer before I explain any more. So all of those divisions were shown in the 3D schematic on this drawing. And I'm just popping them into my drawing now. Luckily, this is symmetrical. So if we drew 1/2 of this, we can just transfer the points across to the opposite side. Okay, so I have the center done as well. And when I transferred over those points, I got the other side, which is great. Sorry, I missed one. So all of these purple lines are essentially the curve A, B, and C be moved along that umpire's chair. The curve D, B, E. Okay, so I have all of the divisions done. I'm going to replicate those divisions up in elevation, but I just don't know how tall they're going to be just yet. So that's why I'm going to do them lightly with my pencil. And I can put them in purple after, but there's no need really, or no necessity. Okay, so now that I've transferred all of my points, I have all the points down in plan. Grab your tracing paper and you're going to put it on the curve ABC, directly on it. Okay, as you can see, I have mine drawn, but I'm going to explain how you do it. So basically, trace directly over the curve. Make sure you get your center line drawn in really accurately, directly on top of it in both directions. Take the tracing paper off, and with your compass, you're going to poke holes through a series of points that you had found on your curve all the way around. The important thing is that with your compass, that at the end of it, your pencil can fit through those holes, because if the pencil can't fit through those holes, you won't be able to transfer the points accurately. So here's where B is initially, and as you can see, this is symmetrical, so those 2 points are the same height, these are the same height, these are the same height, and so on. So there's only 4 points on each side that we actually need to calculate or get. So that's what I'm going to start on now. Okay, and as I said, the tracing paper is really important. You need it in order to solve this. So I am going to label this 1, 2, 3, 4. ABC is going to move 4 times. And as I said, you only really need to get half of the curve all of the time, because it is completely symmetrical in plan and elevation on the left and right, and on the top and on the bottom. So you can cut out a lot of work by just drawing half of this. So I'm bringing B, which is moved to point 1 across. So there is point 1. I'm going to put, because B has moved down, I'm going to put B a little lower. I'm going to make sure that the center line is on the center line. And I'm going to poke the hole through for each of the points. And I'm only just going to do half of it, as you can see. And I'm going to lightly draw that curve in. Okay. This was 1, which corresponds to this point here, 1. So I'm going to bring 1 across, 1 up at 45 degrees to see where it touches the curve. So up at 45 degrees, bring it up until it touches the curve 1, and bring it across, so that's number 1, and bring it across the first line. There's a point. And actually, because this is symmetrical, you can bring it across to the other side too. So we have the top point, and we have point 1 found on each side. Next, we're going to do the same with 2, 3, and 4, but I'm going to do them one by one. So this is 2, and this is also 2. This is 3, and this is also 3. This is 4, and this is also 4. So bring 2 across. Now the curve has moved down as far as this point, and I'm going to call it 2. And I'm going to grab my tracing paper, put it on point 2, put it on the center line as best I can, and poke the points through for a second time. And as you can see, the curve is moving down a couple of millimeters every time. So now that I've done 2, I'll bring 2 across to find the point I'm requiring, up at 45 degrees, and up onto the second curve, which I've just found, and then bring it across, that's number 2, bring it across to the second line on both sides. Okay, so that's point 2 found. Do the same with 3, so the curve has moved down for a third time. It's now here. Grab your tracing paper, put 3 on the point B. Make sure your center line is on the center line and poke the holes through. Redraw the curve. Okay, bring the 3rd point over, and actually that line just wasn't long enough, so I wasn't getting the exact point. So bring 3 across, up at 45 degrees. See where it touches on the base, and then bring it up to the 3rd curve, which is my last one. Bring 3 across to the 3rd line. And do it on both sides. And lastly, we're going to do number 4. So 4 is going down quite low. There it is. Label it 4. B is moving to this point 4. Put B on 4. Put your center line on the center line. And poke the holes through for a 4th time. And you could always do more points if you felt that you hadn't enough points up in elevation to join it to. So bring 4 across, bring it up at 45 degrees and find it on the curve and transfer it into your elevation. So the transferring it is nothing new to your junior cert drawing. The only new piece is the transferring of the parabola. Bring 4 across onto the 4th line on both sides. So now you have enough points. I'm just going to double check that I have all of that. Sorry, I labeled it wrong. Let's double check again. So that's 4 on both sides. This is 3 on both sides, 2 on both sides, 1 on both sides, and then the top. Now that you have all of those points, you can join it as best you can. Now I'm just going to double check. Yeah. Okay. Okay, it is a little bit okay, so I should have rounded that a little bit more, but you get the basic idea. I did this earlier on actually as well, but I had it a little bit more rounded. Anyways, that's just because I should have been using the inside of the curve. Okay, and that is part C of the question, so label it part C. Part D of the question, I'm just going to show you in the exam papers. You are asked, it has been decided to extend the surface of the canopy to provide more shade for the umpire. So this whole shape is going to be enlarged and made bigger. It will be achieved by extending the generating parabola ABC. So this parabola, we need to make it longer. Upwards and outwards. So it's going to go up and yet it's going to go out. And that's a hint, as indicated by the arrows in the end view, to a width of 900 millimeters. On a separate diagram, draw a new end view of the extending parabola. Now, you have space in the bottom corner down here, and I'm just going to kind of bring it into the focus. Okay, so we have space down here in order to draw it. We are asked to draw the original parabola first that we had at the start of the question. Now, we have this on tracing paper, and we can transfer it anywhere we like. Now I'm going to just focus on one half of this drawing, simply because I'm making it bigger, it won't fit in my page if I do all of it. The first thing you're going to have to calculate is what 900 divided by 5 is first, which is 180. So the overall width now has to become 180 wide. I know you can't actually see that. So the overall width on top has to become 180, but because we're only drawing half of this, that's 90. So I'm just going to replicate that in my drawing down here. Drawing a base and drawing a side. Okay, I'm going to measure the 900. Or 90 as it were. And I'm just going to draw that. I don't know how tall it's going to be. I don't know anything about it. But what I do know is I have drawn this exact same parabola before. So B, I'm going to put it on the base. And I'm going to poke these holes through. And these holes were found by divisions that I had. 1, 2, 3, 4. And do you remember I had a height of 40 that I located by measuring up in tens? 1, 2, 3. That should actually be up there, but yeah. So I have a height of 40 and I had my width, and that's where I got my initial curve from. To extend this, you have to go up extra heights and go out extra widths. So grab your compass. Take one of the divisions, and it doesn't matter, so I'm going to go out one extra space. And because the 900 is actually a little bit bigger than that, I'm going to go out 2 extra spaces. I'm also going to go up 2 extra spaces. So instead of 40 high, I'm going to make this 60 high in total. And I'm just going to remind you of how you actually did that construction earlier on. What you would have done is you would have brought, this was B, that was A. You would have brought the first point and solver across the first line. The second point you would have brought it to B, and you would have got the second point, third and fourth. Well, you do the same thing with the last few points. So that was the 4th point, let's say. With the 5th point, a new one that we've made, we bring it out, but we extend it to our next division, which I actually haven't drawn in yet. So the division I had there, just draw a vertical line for it, for both of them. So this is my 1, 2, 3, 4, my 5th one and my 5th one. When I bring it up and connect them, I've got another point on my curve. I'll do the same for the 6th one. So my 6th point is out here. I'm going to bring it out through the 6th point and continue it on till it touches on the 6th division on the vertical. So that's 0.6 and that's 0.5. I'm then going to extend the curve. So that means join the points out through. And what we're really asked for in this question is what would it be if it was 900 wide, or sorry, yeah, 900 wide. Well, half of the 900 when it's divided up into 5 was 180, divided by 2 is 90. So we need to measure 90 wide on this. And I did it earlier on, but I just need to highlight it a little bit better for you. So that's how tall it will be. And actually my pen went a little bit funny. So that's how wide the 90 is. And this is how tall it would be. So that's how big your parabola will be now. Okay, it's to extend it out to the 900 mil. And that is the full question done. Label that part D, because that is how you found the extended parabola. As I said before when we were doing these questions, the part C's and D's of a question I can't particularly help you with generally, because it's taking account of something that you would have studied possibly in junior cert, or it's telling you exactly what to do. In this one it told you to extend the heights and extend the widths. So that means take the same distances that you had to create the parabola in order to solve it. What's really important with this is, if you did this in an exam, you have to hand up the tracing paper. What I would do is I would stick it onto the page wherever you have space. You probably have like masking tape on the day of the exam. So I'd like stick it where you traced it in the initial place. And that shows the examiner what you've done. Okay, and that's how you'd hand it up start to finish.